All right, section 6.7, graphing linear inequalities. This is take 2 of this problem, and you should have already watched a video on it, and we did talk about it today in class, but I just want to reiterate, we are testing each circle to determine if it is a solution to this inequality. If it's a solution, colored in. If it's not, put an X through it. Okay, so it looks like I've tested the point 0, 0, but let's do it again. We are plugging into this inequality the point 0, 0. That means I'm going to plug in 0 for x and 0 for y. If I do that, I get 0 is greater than or equal to 0 plus 2. If you simplify both sides, you get 0 is greater than or equal to 2. Now notice, there are no variables left or anything like that. We're not solving anything. We're just simplifying both sides to see if it makes a true or false statement. In this case, 0 is not greater than or equal to 2, so we put an X through that point because it is not a solution to that inequality. Let's move up the y-axis and plug in the point 0, 2. If x is 0 and y is 2, we get 2 is greater than or equal to 0 plus 2. Simplify, and we get 2 is greater than or equal to 2. Is that true? Yes, because it meets the or equal to part of it. So this point is a solution. It's going to work. So we will plug that in. Let's test one more point. Let's test, I don't know, 2, 4. If I test 2, 4, I get x is 2 and y is 4. So 4 greater than or equal to 2 plus 2. So we have 4 is greater than or equal to 4. That is true because they are equal to. I shall shade that in because it is a solution. Now if you continue this, what you will find is that all of these points are solutions. And you should have tested all of these points to determine that. And you would have determined that all of these points are not solutions. If you plug them in, they do not make a true statement. Okay, so the next part of this, number 2, says graph the line y equals x plus 2 on the graph above. What relationship do you see between the colored points and the line? Well, this is in the form of y equals mx plus b, where b is your y-intercept, so in this case it is 2, and it has a slope or m of 1, so we're going to go up 1 over 1. And you will see that that line, when you graph it, is basically the border of the solutions versus the not solutions. And it looks very, very similar to this inequality. It just doesn't have the greater than part. So what changes? If I just ask you to graph a line, you're going to get a line. But if I ask you to graph an inequality, you're going to get a line plus some shading. Why? Because all of the points that are on the line and greater than on the y work. Those are all solutions. So we will graph the line and shade. Any point that is found in the shaded area is a solution to the inequality. Okay, so for the next part, we had you change the inequality to be the same as the one above, only it was just greater than. So the question was, how does this picture, how does this graph change if it was y is greater than x plus 2? What is the difference? Well, it's missing the or equal to part. So how would that change? Well, it's going to change the line, but not the shading. The line still has to be in the same place because y equals mx plus b would plot it the same way. However, if you test the points on that line, they would not work. So, if you recall, when we plotted things on a number line, inequalities on a number line, if they were or equal to, we had a closed circle with shading. But if they were just greater than or just less than, we had an open circle with shading. Same way here, we're still going to have the shading, but instead of having a solid line, we would have a dotted line if it was missing the or equal to part. So, let's skip down to the back of your notes here and let's do a few of these examples, okay? In class we did example number 1, so I'm going to go ahead and skip to example number 2. In order to do this problem, the very first thing that I'm going to do is I am going to put it in slope-intercept form by dividing by a -1. So I get y is greater than or equal to, we had to flip the sign because we divided by a negative, -4x plus 5, because a negative divided by a negative is a positive. In the form of y equals mx plus b, the b or the y-intercept is 5. So we put that on the y-axis. And then we use our slope to find additional points. So we've got -4 over 1. So using rise over run, we're going to go down 4 over 1. Down 4 over 1. And I do as many points on the graph as possible, and then I ask myself, should I draw a solid or dotted line through that graph, or through those points? And in this case, I'm going to draw a solid line because it has the or equal to. And then I'm going to say, okay, well, where should I shade? Where are the y's greater than? Well, I have part of a y-axis up here, and I have part of a y-axis down here. Where are the y's greater? Up here, so I'm going to shade that part of the line. Now that is one option for determining which direction to shade. You could also test a point on either side and determine if it's a solution or not. If it's a solution, then you shade that side. If it's not a solution, then you do not shade that side. Okay, let's look at problem number 3. Y is greater than or equal to 4. Because the slope here is 0, or there is a 0x, that means it is a horizontal line with a y-intercept of 4. Then I ask myself, okay, solid or dotted, and you can see I did a solid line because of the or equal to. And then I say, well, which direction do I shade? Well, it wants the y's that are greater than, and I know that the y-axis is greater than above the line. Below the line would be less than. So these are where the greater numbers fall. Okay, number 4, x is less than -2. So if y equals something is going to be a horizontal line, x equals something is going to be a vertical line. So we'll start by graphing the inequality just like that. It's going to go through the point -2 on the x-axis, but this time we're going to have a dotted line because it's just less than. Doesn't have the or equal to. And it says that we want all the numbers that are less than. Well, where are the lower x's? Because we want x is less than. So where are the numbers that are less than -2? To the left. Again, you could test a point, any point that you want. So if I test the point 0, 0, I would only plug in 0 for x because there is no y, and I would say, is 0 less than -2? No, so I do not shade that side. Number 5, I'm going to put that into slope-intercept form first. So I'm going to subtract 5x from both sides. And then I'm going to divide by -2. Now when I divide by -2, that makes me flip the sign because I divided by a negative. And I have a positive slope because a negative divided by a negative is a positive. Plot the y-intercept, which is -5, on the y-axis. Then I use the slope 5 over 2, so rise 5, run 2, to get additional points. This graph is going to have a dotted line because there's no equal to part of it, it's just less than. And then if you want the y's are less than, we say, okay, well there's a y-axis up here, there's a y-axis down here. Where are the y's less than? The y's are less than down. So I should shade this part of the graph. Again, if you would like to test a point, a good point to test is 0, 0 to see if it would be a solution. For number 6, I'm not going to go through the entire thing, but y is greater than -x plus 0. That's the key here. Your y-intercept is 0, your slope is -1, and then you will shade to the greater than. Okay. Write an inequality for each graph. So first of all, I would say Okay, this is shaded down, so this is going to be less than. Do I need an or equal to? No, because it's a dotted line. So I'm going to have y is less than a slope of, let's see, where are some points here? Got a point here and a point here. 2, 3 for rise over run. The line is going up, so it's positive. 2/3 x. The y-intercept, the b, is -2, so -2. Number 2 is going to be less than because we're shaded down. So we're going to have y is less than. Now let's talk about our slope. Here are 2 points. We're going down 1 and over 1, so we're just going to have a -1x, and then it goes to the origin, so it's +0. You could also just write this as y is less than -x, either way. Number 3 is a horizontal line, so we're just going to have y. There's not going to be an x in our problem because the slope is 0, and it goes through the origin, so it goes through 0. It is shaded less than. It is dotted, so there's no or equal to. This is your inequality. I do have to go back to number 2 because I just noticed that we put less than, and because it's a solid line, it should be less than or equal to. Okay, so your homework tonight is the worksheet 6.7, and you know what? Let's do odds. Okay, worksheet 6.7. Let's do the odd problems, please. See you in the morning.